All right, so we are now going to be moving to the second major strategy that is being used to protect biodiversity, which is called protected areas. I know by now you are probably feeling pretty depressed, about the fact that we're talking about very beautiful thing, which is very unique, which is this diversity of species that we share the planet with, that they are declining around the world. And unfortunately, we already know why they are declining: over exploitation, habitat loss, climate change, overconsumption, and overpopulation, invasive species. And we also know that there are ways that we can save these species, but unfortunately, as we saw last class, these strategies are not being effective. Today, we're going to be moving to a second strategy that is being used to protect species, what is called protected areas. And unfortunately, you are depressed by this moment. This class today is not going to make you feel any better, because protected areas are just as bad at protecting biodiversity in reality. While in practice, just like the regulation policies, they make a lot of sense. In practice, they don't work as well as we think. So we already established that there are these stressors that we put on biodiversity, from the deforestation, habitat loss, overexploitation, and climate change. The idea here is that we can use protected areas to kind of mitigate some of these stressors that we put on biodiversity. The idea of protected areas is relatively simple. Basically, what happens is we had an ecosystem, and in that ecosystem, you had a species. Now, what we do is we create these imaginary boundaries. Keep in mind that this idea of countries or protected areas, those are human concepts. Basically, what we do on those places is to say there is this area that is defined by these boundaries, and inside those boundaries, basically what we want to do is we don't want you to fish, right? It could be the same on land as well. In the case of land, we say, okay, this is a forest, and inside these boundaries, we are not allowing you to go and cut down the trees. But let's keep on the oceans for a moment. We have these boundaries again. Inside those boundaries, we say, okay, you are not going to fish there. The expectation there is that by us stopping fishing, we reduce mortality, which is, again, what we just saw has a negative effect on the sizes of the populations. And by us reducing mortality, what we do is we allow the fishes to become more abundant. The fishes manage to live longer because they are not being killed. So the fish get to become adults and produce offsprings then that have higher capacities to survive. Not only adults that are big can produce a lot more offsprings, those offsprings actually have a better chance to survive. So this is the theory behind protected areas. Again, basically, we create some boundaries. Inside those boundaries, we tell people, don't go and fish. The expectation there is we reduce mortality, allowing fish to survive, grow, become more abundant, and produce more. Now, the other benefit of protected areas is that inside those areas, we are also telling people, you cannot come and destroy this. It's not like you are going to go and take a bulldozer and cut down the forest in an area that is a protected area. So you also constrain biodiversity loss, and basically you allow to have the habitat being protected so that the species can survive there. So there is a win-to-win, so to speak, behind the theory of protected areas. Again, just regulating the harvesting inside those areas or the destruction of habitats inside those areas. And the expectation, again, is that you will protect the habitat, allowing individuals to grow better. That's the theory of it. Now, how good is the evidence, right? How well are these protected areas doing around the world? So there is this very famous paper by Silic and Bruno, and they analyze protected areas from around the world. These are protected areas on the ocean, in the ocean, okay? And what they found was that when you look at things like changes in coral cover, where the corals are surviving or not, inside protected areas versus outside, what they found was that in the Caribbean, the Indian, and the Pacific Oceans, places inside coral reefs inside protected areas are actually doing better. The coral reefs inside the protected areas are doing better than outside. So that was a kind of a remarkable finding. And again, that was found in the Caribbean, Indian, and Pacific Ocean. So this is one of the first evidence to suggest, wow, these MPAs telling people don't go and fish and don't destroy the habitat is actually allowing coral reefs to do better there. This is one of the first pieces of evidence to support that idea. This is another paper done by, I think, Sarah Lester. I think that she was at the University of California at the time. In this one paper, they took data on all of these MPAs from around the world. And in this one, they were looking at things like biomass, density, the sizes of the fish, and the diversity of species on those MPAs, and they analyzed that inside these protected areas. What they found was, again, as you can see here, the biomass of fish was 446% times bigger inside protected areas than inside. The density of fish was almost 166% more larger inside protected areas. So this is another piece of evidence to suggest that protected areas are actually doing the job. Again, the paper by Bruno pointing out that coral reefs do well, and this paper by Sarah Lester pointing out, yeah, fish actually manage to produce a lot of biomass and they become quite big inside these protected areas. So basically what these couple papers did, in addition to other papers, was to provide some hope that we can actually use these protected areas to save the species in the oceans, and there is similar evidence for the land. So the conclusion of the paper by Lester was this, basically that these marine protected areas can be used as a globally important conservation and management tool, right? So keep in mind, if you look at where they took the data, was only a few places from around the world. Despite the fact that the places are found everywhere, these protected areas are relatively small, only a couple kilometers square. But then they stretched that conclusion to suggest that these protected areas can be used globally to save biodiversity. Not surprising, what happened as a consequence on these and several other papers is that the number of protected areas in the world just skyrocketed. So you can see here, obviously, countries on the world want to save their species, but basically what happened was that they skyrocketed the use of protected areas both on land and in the oceans. This is the number of protected areas on land, which is a paper by Chape, and this is the area of protected areas in the ocean, and this is a paper by Woods from UBC. And again, on both cases, you can see that the use of protected areas was used exponentially around the world, again, because there is this desperation of people to save the biodiversity on land and in the ocean. These papers start coming out saying, yeah, this species actually recovered on these places, so let's use this globally. Now, my question though was this, and this is when I start investigating this on this one paper. So we already know, when you look at the protected area, the area that is being protected by protected areas, you can see that it's going up in land and it's going up in the oceans. As I explained to you, there was scientific evidence to suggest that species recover inside these protected areas, and that was found on land and in the oceans. And not surprising, countries from around the world start using these protected areas quite a lot on land and in the oceans. But my concern was that when you look at the biodiversity of the planet, it turns out that biodiversity is declining. So for me, this observation was striking. How is it that we are using something that we know works very well, which are these protected areas, and countries are just producing them like crazy, like nobody's business, yet biodiversity is declining both on land and in the ocean? So something just doesn't add up here. How is it that these papers are claiming they are good, these protected areas are good, but the diversity of the planet just continues to go down? This paper was criticized because they say, well, maybe you are doing it at a too larger scale. Well, it turns out that I did that for coral reefs, which are ecosystems that are very protected in the Caribbean and the Indo-Pacific, and I found the same pattern. In the Caribbean, the coral reefs are increasingly being protected, which is that blue line, but coral reefs continue to decline. In the Indo-Pacific, the same thing. The area of coral reefs inside protected areas goes up, but the coral reefs decline, right? So it's kind of weird, right? So basically, we're trying to preserve coral reefs and ecosystems using protected areas, but the biodiversity continues to decline, despite the fact that there were scientific papers saying that these protected areas work. So something doesn't work here. What is it? It turns out that when you look at the logic that I explained to you earlier, for these protected areas to work, they need to be effective. And this keyword, this becomes an important keyword here. Are the protected areas on the world effective? Right? One thing is for you to say that you're going to do something. The other way is whether you can actually do it right or not. So we decided to start breaking down this issue of effectiveness, right? How do we assess whether the MPAs of the world are effective or not? I decided to break that effectiveness into three components. The first one is biological effectiveness. Biological effectiveness refers to cases where you establish a protected area and there is a result that is observed on the ecosystems recovering, right? Again, the idea here is that the protected area will ensure that the populations remain viable, For that, you need to ensure that the protected areas are connected. You guys remember one of the things that is important to maintain a population is to ensure that the populations are connected. So these protected areas need to be deployed in places that are close enough for the populations from the individuals from one population to get to the other one. So these networks of protected areas need to be close enough for them to ensure that the populations are connected. The protected areas also need to be large enough so that the fish or the animals don't wander around the MPA and get killed outside. Okay, so if the fish gets outside of a protected area, yes, while it's inside the protected area, it's protected, but if it gets outside and it gets killed, then you cannot defeat the purpose of the protected area in the first place. So you need to ensure that these protected areas are large enough for you to ensure that the fish stay within the protected area. And obviously, you need to ensure that external threats like pollution, sedimentation, don't destroy the habitats inside that protected area, right? So it turns out that given sedimentation, things that are done on land can influence what is in the ocean. So you might be protecting things in the ocean that can be impacted by things outside the protected area. So these are attributes, again, of the network of protected area that need to be assessed to ensure that they are effective. They need to ensure that the populations are connected. They need to ensure that the MPAs are relatively large for them to protect this fish. And they need to ensure that external threats ensure that the area that is protected still remains suitable. That is what I refer as biological effectiveness. Now, the other attribute of effectiveness is what is called management. In this case, the ultimate goal of management here is to ensure that we restrict human activities, right? So basically, the ultimate purpose is to reduce fishing or the destruction of habitat. So how do we ensure that that management is effective? So again, here, basically what happened is that we need to have certain attributes in place to ensure that the MPAs are effective. One is enforcement, so that when we say, okay, this area needs to be, nobody can come in here and fish, you need to have a policing group, police officers or military or whoever, that ensures that nobody goes there and fish. You also need to have compliance, right? Which is people respecting the boundaries. If you say there is a boundary and you cannot come here, you need to have people around that respect and don't go there for the fish to survive. And the other one is illegal fishing or poaching, right? So these are attributes that you need to measure to ensure that the network of protected areas is effective. And the other one is feasibility. This one I find it very interesting, and I think that that's when the papers by Bruno and Lester kind of stretch their conclusions when they suggested that these things can be used globally. When you go from doing something at a smaller scale, like in Waikiki, for instance, and you say to people, don't come and fish, you can hire 3 police officers and patrol the whole thing. One thing completely different is to say, okay, I'm gonna now increment that to the scale of the entire planet. It's gonna get out of control to establish that. One of the several things that you need to account for is cost. How expensive it's gonna become then to have these protected areas implemented around the world. Do we have the money to do it, right? So here, again, what I try to point out to you, just like we did with the fisheries, with the assessment of the management of the fisheries, was to come up with attributes that allows to assess how well are the protected areas in the world protecting biodiversity. So let's look at the first attribute, which is this biological effectiveness, right? So this is a paper that I did with my supervisor, Peter Sell, back in the day. Basically, what we had here is, as I explained to you, we had the size of a population. You know that the population is affected by the inputs, which is natality or recruitment, immigration, and by the output, which is mortality or emigration. So those 4 factors, as we established before, determine the size of the population. The idea here of MPAs affecting biological effectiveness is that it will influence recruitment or natality. So when you have the populations, the MPA is close enough, you ensure that the populations will have enough recruitment to ensure that the populations are maintained. Let's look at how well they do. So just a little bit of background information. When you have marine ecosystems, you normally have patches, right? The coral reefs are normally not continuous. They are located in patches. That means that the only way that individuals have to go from one place to another one is via the larval period. So basically, you get adults, they produce the eggs turn into larvae, and then once the larvae get certain amount of time in water and they grow to certain size, they recruit into the coral reefs. And that's how, again, species manage to go from one place to another one. The idea here of this protected area is that if you imagine this protected area, this boundary that I created in red, we need to ensure that these areas that we protect are within the range in which this species can disperse. In this example, I had two protected areas, one protected area here, one protected area there. If you see the fish reproduce here, but the larvae managed to never get there. That MPA was just too far. So again, it's important that when we think about the design of these protected areas, they are close enough such that the larvae from one area that is protected can get to the other one. So again, here, if these protected areas are to be effective, we need to ensure that they are close enough for them to ensure that you get recruitment or connectivity between populations. Now, the other aspect that protected areas can influence is what is called mortality, all right? So for the protected area to be effective, it needs to be large enough to ensure that you prevent the fish from being killed by fishing. So let's look at an example here. This is a species of fish that is used to live right here in Waikiki. This one in red is the area that is protected. This is a protected area, and the dots is the geographical position of a fish that was marked, and I believe it's a fish of Muloidoctis. It's like the goldfish. You can see how this fish, during several times of the day, moves outside the boundaries of the protected area. This suggests that this MPA is too small. It's small because what happens is that there are times when the fish moves outside, and basically people can perfectly not fish inside here, but if they are allowed to fish outside, the fish will get killed here. So this is another attribute in which protected areas need to be assessed for them to be effective, which is to find out, to ensure that they are big enough to ensure that the fish are protected, even to ensure that they are contained inside the protected area. So again, for the MPAs to be effective, they need to be large enough to ensure that their home range that they move around is protected. The other attribute of protected areas that is important is the suitability of the habitats. So here is an example of many habitats from around the world becoming unsuitable because of climate change. So you can have a protected area, but if the temperature of the water becomes too hot, then you are doing nothing there. So again, for these protected areas to be effective, you need to ensure that the environment that is protected is still suitable for the species to grow there. So you can see how for these protected areas to be effective, there are a lot of ifs that they need to fulfill. They need to be close enough to ensure that the populations are protected, can connect with each other. They need to be large enough to ensure that the species are protected, the individuals are protected inside there. And you need to ensure that the habitats, the environmental conditions that are protected are still suitable for the species to grow there. So that's when things start breaking apart for the MPAs, because there are a lot of conditionals that need to be fulfilled for them to be effective. So let's see how well they do though. So we already established there are attributes that need to be fulfilled for them to be effective. So this is another paper that I did. The first one again was to see whether the protected areas are large enough for you to protect the home ranges where the given individuals survive. It has been found, for instance, that if you want to protect at least half of the species of fish, it is suggested that the MPAs need to be at least 1 kilometer square or bigger. So if the MPA is smaller than 1 kilometer square, most of the fish, over half of them, will move outside that MPA. So you need to have MPAs that are bigger than that. When you look at all of the MPAs in the world, however, we found that only 28% of them are larger than 1 square kilometer. So we are talking right there, this attribute alone, almost 70% of the MPAs in the world are just too small, right? Again, for them to work, they need to be larger than 1 square kilometer, but the reality is that of all of the MPAs that are in the world, only 70%, only 28% of them are large enough. As I told you, another important attribute for those MPAs to be effective is that they need to be close enough. It has been suggested that the distance, the separation between MPAs gotta be at least 10 kilometers apart from each other. That's the minimum distance that you will need for the individuals that are producing one MPA to get to another one. Again, the critical value is 10 kilometers of distance. If the MPAs are larger than that, the offsprings that are produced by this MPA will never get to the following MPA, 10 kilometers. Now, when you look at all of the MPAs on the world, the distance between all of the MPAs in the world, what you find is that only 52% of the MPAs in the world are close enough. 48% of the MPAs on the world are too far apart. So you can see here how of all of the MPAs that are in the world, 70% of them are too small, 48% of them are too far apart. And the last attribute is suitability. Is the habitat, the environment inside those protected areas suitable or not? And for that, we use something that is called the human footprint. These are things like pollution, coastal development, climate change, and whether those attributes were influencing the protected areas on the world today. And what we found was that of all of the MPAs in the world, 83% of them are located on places that had a very large human footprints. Only 18% of the MPAs in the world are located on places where there is not a human footprint, right? If you think about it, human development has been massive, human expansion, sorry, has been massive on coastal areas. So most of the areas around the world's oceans are already occupied by humans, and there is a huge impact there, like coastal sewage, ecosystem runoff from agriculture and things like that, to the point that of all of the MPAs that are in the world, only 17% of them are located on places where there is no human impact. So you get the picture here, how, while there might be a few MPAs here and there that will become effective, the reality is that the great majority of them are either too small, too far apart, or in areas that cannot be protected because there is just a lot of external sources of impact. And here is where I start explaining why things start breaking apart. From those few studies that were analyzed by Lester and Bruno, pointing out that MPAs are good, to trying to extrapolate this to the global scale, and you start realizing all of the different limitations that will prevent these MPAs to be effective, and why is it that despite the fact that the MPAs continue to grow, biodiversity continues to decline, again, because they are too small, too separated, or impacted by external stressors. Now let's move on to the second attribute of management. This was another paper that we published, and in this specific paper, I wanted to find out how effective is the management of the world's fisheries. In this case, I was not interested again on the biological attributes, where they were small, connected, or affected by external stressors. I was interested in finding out, are governments of the world doing a good effort to ensure that there is good enforcement of the regulations as to restrict human activities? For this one project, I analyzed all of the MPAs in the world that had coral reefs. So I talked to databases. One database is the protected areas of the world, the marine protected areas on the world, you can see them here. And the other database was the coral reefs of the world. I overlaid the two of them, and basically what I did was to select any MPA in the world that has coral reefs. The total number of MPAs in the world was 1,344 in 102 countries, and they covered 21% of the world's corals. Right here, you can already see a limitation in the extent to which only 21% of the world's corals are inside protected areas, okay? But I wanted to know more. What I wanted to know was how good are those MPAs? Again, one thing is to say, I'm gonna protect it. A different thing is to put money to ensure that it is effective. So what I did here, again, was to assess whether those MPAs were good or not. And what I did, I sent an email to 1,000 people from those 102 countries, and I asked them whether they could please tell me whether those MPAs were good or not. And after sending that email to 1,000 people, I only got 5 replies. That was the largest investment of time for the less return on data that I had ever done in my life. It took me a long time to get these emails from these people, but the mistake that I made was that I sent the email in English. And unfortunately, only about 5 countries in the world spoke English. Most of the other countries spoke different languages, and that kind of explained why I got such a few replies. So what I did, I converted my survey, translated my survey into 5 languages. And because some of these countries are so far apart, some of them actually don't even have internet. So actually, I started to call these people by phone. What I wanted to do was to ensure that every MPA in the world, every one of the 1,344 MPAs, I got a scientist telling me whether that MPA was good or not. And basically what I ended up doing after I reviewed all of the MPAs was to find out that the area that is covered by those MPAs is 18.7%. But now I can break it down into how effective that was. What I found was this. That 18.7% breaks down into only 1.4% that are inside places that are called no-take. Those are areas that are defined as completely no fishing at all, right? So in some places from around the world, they say the protected area is an area that is protected, but you allow still people to go and fish and do all kind of crazy things in there. But there are these ones that are called no take, in which nothing can be taken out of them, and those ones are supposed to be the best ones for a species, but only 1.4% of the world's coral reefs is inside those protected areas. So you can see how the whole thing breaks down just on this, right? 18.7% of the world's coral reefs are inside protected areas, yet only 1.4% of that is inside not take. One thing is to say, okay, the government say that you cannot fish. A completely different thing is whether people is actually respecting the law or not. What we found was that the total area of the world's coral reefs, only 0.1% is in places that are not take, that have no poaching. So again, only very few places from around the world, in fact, only just 2 MPAs in the world claim that they are not take, and people actually respect those laws. 0.1% of the world's coral reefs, and only 0.01% of the world's corals had not external risk. So you can see how, again, a beautiful strategy, beautiful in theory. In practice, we are having a lot of MPAs protecting coral reefs, 18.7% of them. But when you assess whether that protection is good or not, you find, yeah, you are still letting people fish on those places. You are still allowing people illegally to go and fish there. And on top of that, you are located on places that are being impacted by external stressors. To the point that, again, of all of the world's coral reefs, only 0.01% of them are in areas that are relatively well, like the best MPAs in the world. For every MPA in the world, all of them, I collected different attributes, and I put all of those attributes in a scale that ranks MPAs between being adequate to MPAs that are very limited, okay? So those are the 4 categories in which I integrated all of these different attributes, and those are the results that I found here. Okay, so now here we can see the results of how effective are the MPAs in the world. In Africa, the coral reefs are actually just located on the east coast of Africa, and those boundaries that you see there, those yellow and red boundaries, are the MPAs. And as you can see on this figure here, there are 59 MPAs in Africa that cover only 9.9%, but you can see that most of that coverage is really not that great, only a fraction being adequate. Now, in the Middle East, there are 29 MPAs. They are huge. You can see that they cover 18% of the coral reefs there. And they are actually adequate MPAs. In the Indian Ocean, there are only 37 MPAs, and they only cover 2.6%. You can see that the coverage is really almost nothing in the Indian Ocean. Southeast Asia has lots of MPAs, 345 MPAs covering 12%, but you can see that most of those MPAs are not really that great. Australia is, again, a nice surprise, because Australia only has 23 MPAs, but they cover almost 70% of the coral reefs there, and most of those MPAs are actually effective. There are almost no MPAs that are limited or very limited in Australia. We move on now to the middle of the Pacific. Lots of MPAs there as well, but you can barely see them by comparison of how huge the Pacific Ocean is. Almost 200 MPAs, but they only cover 8.3%. Almost all of them not being effective. The Eastern Pacific, where I'm from, there are 24 MPAs covered in coral reefs, and they cover only about 21.8%. You can see the Galapagos Island right there. That's a huge MPA. But the coverage is not really that great. As you can see, only a fraction being classified as adequate. The last region that we analyzed was the Caribbean. Lots of MPAs there as well, 219 MPAs covering over 20%. But you can see that only a tiny fraction of them are adequate. And those right there are the MPAs in the world and how they protect coral reefs. As you can see, they are mostly all of them very small, and almost all of them inadequate at protecting the coral reefs on the world. And then you are left with still 80% of the world's corals that have no protection at all. So those right there are the marine protected areas on the world, and how good are they at protecting coral reefs? Okay, so again, I want you to just realize that we are losing ecosystems when it comes down to the oceans, and we had the general motivation to protect that biodiversity that is on these ecosystems, and we already established here that one of the potential mechanisms for us to protect biodiversity is via the use of MPAs. up to now, I had showed you multiple pieces of evidence to suggest limitations on the extent to which these MPAs are actually effective at protecting the world's biodiversity in the ocean. We established that 52% of the MPAs are just too far apart for them to ensure connectivity among populations. 28% of them are just not big enough. You know, most of the MPAs are actually too small. The assessment that we did on the coral reef suggests that only 0.1% of them are well managed to prevent fishing. Can you imagine? Of the entire majority of the MPAs, they are still so poorly managed that people can come and just still do fishing there, despite the fact that that's forbidden. And still, despite the fact that that's a massive effort that has been put in place to protect biodiversity, as we saw earlier, there are still over 80% of the world's ecosystems still with no protection whatsoever. And that again just gives you the picture on why biodiversity continues to decline, despite the fact that we are increasing quite a lot the use of protected areas. So I really want us to go back and review this statement that was done by Sarah Lester. Again, several people had done this statement before, but she is the one that summarized it the best, in my opinion, which is again trying to use these marine protected areas or reserves as a global. And I think that that's my problem there. It's trying to take something that works well at a small scale, trying to take it now into a global scale, and I think that it falls short. So we really, given what I just showed you there, the fact that MPAs increase biodiversity declines, and when we did the assessment, we actually proved that these MPAs had many reasons for why they can fail. We need to start reevaluating the evidence of why are these MPAs failing. Again, if we are really truthful and excited about protecting biodiversity, we need to be very critical about why things fail. We can just not really just walk away with the first thing that shows positive. It is not about being negative, it's about being realistic. If we fail on these things, the consequences are going to be paid by many of these species. So I'm a person that personally, I just get very pissed when people think that this is being negative. No, you really want to do the best job you can. So if there is something being proposed, let's ensure that that thing that is proposed is effective so that we can achieve the goal, but we can just not start implementing things that work halfway because the ultimate impacts are paid by species. So I want us to reevaluate the evidence, and then the next part of this class, we're going to evaluate what's really the potential limitations of this statement. So we need to start by assessing how is it that these people quantify whether MPAs are good or not, right? So they go and look at an MPA and they say, yeah, biodiversity is actually very good on this place. How do they do this? So there are two ways to do it. One is what is called before and after. Basically, they analyze the MPA right now and the MPA later. The other one is basically what is called inside versus outside. Basically, you create an MPA, you look at the biodiversity inside, you look at outside, and you compare biodiversity inside versus the outside, and that way you determine whether the MPA has a positive effect or not. And here again, it's just where the MPA over time becomes better or not. Now, it turns out that these ways in which we measure biodiversity inside protected areas is biased. Let's look at the first case. When you analyze the MPA now with the biodiversity with the MPA later, what happens there is that if you haven't removed or stopped people from fishing, basically all what you had done is to move people from the inside of that MPA to fish on the outside. Again, all what you had done is what is create fishing displacement. You take the people from the inside, you take it out, and people start fishing in the outside. Basically, what happens is that now you increase the number of people fishing in the outside. The populations in the outside decline, and as a result, the populations from time to time will increase. It will create the signature that MPAs are working because you see protected areas, inside protected areas, to the biodiversity increasing, but the reality is that the fishing remained the same. All what you did was just to move the pressure from the inside to the outside. Now, the other limitation when you are trying to quantify whether MPAs are good or not based on the inside versus outside is that normally MPAs are created in places that had higher biodiversity to begin with, right? That's the motivation, is to protect a species. So normally those MPAs are chosen based on whether they had good biodiversity there or not. So the limitation here is that you start with MPAs with good biodiversity to begin with. So whenever you want to compare the biodiversity inside versus the outside, you might find that the MPA has good biodiversity, but it's not. It's because the MPA might have done nothing. It's just that you begin having good biodiversity to begin with. So those are a couple limitations that have been highlighted in the literature as to why there might be a bias when we say that MPAs are great. And all of these results that have been shown could be a simple limitation, again, in the way that we have quantified whether MPAs are good or not. Now, the other limitation of MPAs is the fact that they are very short in the time frame in which they have been studied. So we know that ecosystems normally had an incredible variability. And here's just an example. Imagine that this is time and this is the number of fish. You can imagine that the number of fish changes quite a lot over time, despite the fact that there is a general homogeneity of that variability. The problem with this is that when we go and calculate whether an MPA is doing well or not, if we do it at a small scale, a small temporal scale, like in this case example, let's say that we go there and now we go here and here, you can see, okay, wow, MPAs are pretty good here and they were relatively bad there. So you can see that because of the use of the small scale, you can actually find results that are significantly different. But if you were to look at a large scale, basically what you will see is that there hasn't been any change. And that creates a limitation again, that when you analyze data that comes from a small scale, either in time or in space, you might end up finding variability, but that variability might not be common on a large scale. The problem with this is that when it comes down to scientific publications, normally most of the publications that are being done are publications that have significant results. So whenever you get a publication submitted to a journal, most scientific journals are only going to publish when you show that there are significant results, meaning that imagine that it's 50-50 in the cases where they work and they don't work. But if scientific journals are only publishing cases when there is significant effects, that means that the cases where there is no effect, they don't get published. So when these people go and collect this data to create this meta-analysis to say that MPAs are working well, it might just be a biased subset of all of the papers that are there, because again, scientific journals only allow you to most commonly to publish significant results. Here is an analysis some students of mine did back in the day, and basically what they did here was to look at the extent to which publications had shown that MPAs had negative or no effect, or the extent to which they had positive effects, right? And what you can see here is that the MPAs that had positive effect, those papers start getting published early on. You can see a lot of papers being published of MPAs showing positive effect. It was novel, and again, many journals were publishing significant results, so that explains why there are a lot of papers being published early on showing that there are positive effects. Now, later on, when now it became established that MPAs are relatively good, papers that show that there was no effect or the effect was negative start becoming novel, because now those papers were challenging these papers. But you can see papers showing negative or no effect being not published at all early on. There were almost no scientific papers saying that MPAs were negative or had no effect early on, because again, there were no significant effect. But once these papers that were showing that there was a positive effect started to create a paradigm, that a theory that MPAs were good, then these papers became novel, and that's when you start seeing them getting published, to the point that now later in the latest decades you can see papers that are positive and negative being published almost as common. Again, that just to point out that it's possibly that all of these conclusions that have been made that MPAs are good could have been the result of a bias in the extent to which papers are getting published in the scientific literature, because early on, most of the papers that probably were published were papers that show significant effects, while those papers that showed no effect were not published until later on. Now, the other limitation of those papers, of many of those papers that were published pointing out that these protected areas were great, is the fact that they were, almost all of them were based on what is called marine no-take areas, right? No-take means a level of protection in which nothing can be taken. There are some places, some of these places actually don't even allow people to go and swim in there. So there is a very strong conservation on those places. But the reality is that those protected areas, when you look at the oceans, for instance, there is a paper by Woods, I think her name is Sarah Woods, You can see all of the area of the world's oceans over time that are under total area of MPAs and the no-take MPAs. Again, these no-take MPAs are the best protected areas in the world, right? But you can see that they represent only a tiny fraction of the world's oceans. Most of the MPAs are actually places where you can go and fish, you can go and swim, you can take your boat. But those MPAs where protection is heavily, where it's strong and enforced, which are not take, they represent only a very, very small fraction. So in this case, it's possible that all of those conclusions pointing out that MPAs were great at protecting biodiversity might come also from the fact that maybe they were based on a subset of MPAs that are relatively good, but they are incredibly, incredibly rare, which are those not-take protected areas there. So let's try to summarize everything up to now. So we know that, again, there is an increasing motivation of countries in the world to protect the biodiversity. Other countries, one strategy that has been proposed is the use of protected areas. There is a lot of scientific data suggesting that protected areas can work. That evidence that was put forward created this frenzy for countries to create protected areas like crazy. Yet, when you look at biodiversity continues to decline despite the fact that MPAs continue to increase. When we went and analyzed what is happening there, we discovered that there are multiple limitations that prevent protected areas of being effective. They are sometimes too far apart, sometimes they are just too small, sometimes they are affected by external factors, and even in the cases that they are implemented, the enforcement in most countries from around the world is relatively very small. So there you can get the picture of why these MPAs are not working. Now, when we go and review back the evidence that was put forward to begin with, we found that there could have been potentially many limitations of why these people early on concluded that MPAs were great, that they were great. It could have been related to the fact that they use different, there were errors in the ways that data was calculated. Maybe there were errors on the extent to which papers that were published were normally showing significant results, while all the papers that show no effects were not published, and that led them to then use a biased subset that then led them to make these conclusions. Or it could have been the fact, as I point out here in this last slide, which is the fact that they use a subset of MPAs that are relatively very good, which I'm not denying, which are those not take, but these not take MPAs really represent only a super small fraction of all of the MPAs in the world. So that summarizes right there how well are we protecting marine biodiversity with the use of protected areas. And it's kind of the same deal on land as well. Let's leave the class there for today.